everybody. This is day 1 of geometry, first day of term 5. And the do now today, you all have already done it. If you are here, you all have green folders with your names on them, and we're all sitting in seats that we've chosen. We just went over the classroom agreement together. Took up about the first half of our class. This is what I'm referring to. This is in your folder. And we just talked about the exit ticket, your first assignment for this class, that you will write down days that you won't be here. Tell me anything you want me to know. Sign it, put the date. You'll turn it in to me. That's your first assignment due on Friday. So, moving on, now we're going to get to our first lesson ever. We're going to talk about measuring things. And we're going to talk mostly about inches today. And you'll notice that I also gave you this handout. It says the giant inch. Okay. So everybody should have this paper at their, and something else you should all have is in those little rectangle colorful bins, there should be some rulers. So let's all go ahead and get out a ruler. If there are not enough rulers at any of the tables, just let me know. I have plenty of extras. Everybody needs a ruler. I'm going to explain how we use this giant inch to help us measure things. So on a ruler, there's lots of little markings. You're going to see that when you flip it over, there is, on the very left side, you'll see something that says 0 cm. When you flip it again, you see 0 inch. We want the inch to be facing up, the one where the marks are further apart. That's what we are looking at today. And the way that this giant inch works is it is just a zoomed in version of this little tiny space here. So what I'm going to have you do is take your ruler. I'm going to move this beneath. And we're going to draw a little picture on this paper together. I'm going to put my ruler down like this. And I'm going to draw a line. Oops. Kind of like that. It doesn't have to be a specific length. And on that line, I'm going to mark my inches. So the first mark that you're going to make is where this big line is right before the 0, the first line on the ruler. That's your starting point. The next line I want you to mark is right on the big line next to the number 1. Like that. Okay. And then mark 2, we'll mark 3, we'll mark 4, 5. You can mark as many as you want. We're just going to get kind of a scale going here. Okay, so what I'm going to do now is show that here's my 0, here is my 1. This giant inch is the zoomed in version of this little tiny inch. So what we're doing here is looking at what each of the little lines on your ruler are telling us. It's all these fractions. So we can label these more if we like. And it just goes on. So we're going to use this to help us, like that, zoomed in. And that's all this is. It's just a little guide to see kind of the zoomed in markings on our rulers. So for example, on the giant inch, if I start here at 0 and I go over 1, 2, 3, 4, 5 spaces, for example, I'm going to land on 5/16. The reason is because there are 16 little marks in between every inch. We look in terms of 16ths of an inch. There are 16 little marks in between each inch. So if I were to measure something that was 5 little marks past the first mark here, past 0, I could look at my giant inch page and say, well, I went 5 spaces, 1, 2, 3, 4, 5. It's 5/16 of an inch. So let's pull out this little paper here, measuring line segments in inches, and we're going to kind of practice this skill. And I'm going to zoom in as much as I can. And our directions say use a ruler. First of all, this is a ruler. If you've never seen one before, it's a ruler. And we're going to measure each of these line segments in inches. We're going to round our measurements to the nearest 16th of an inch. So we're going to look for the line, the little line that is closest to the inch. Now, when we measure, 2 options. Should I line my ruler up here or here?
0.
Yes, the second option is correct. This first line is our starting point. If you measure from the end of the ruler, you're not going to get the correct measurement. It needs to start here. Does everybody see that, or do I need to zoom in anymore? So what I am going to do is I am going to count how many of these lines over that we go. And something I discovered while I was kind of messing around with this worksheet is it's sometimes easier to count them from the bottom where the lengths are different because you don't lose your spot as easily. So I'm going to count from here's my starting point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10. I counted 10 little spaces. Since there's 16, I know that's 10/16 of an inch, right? Now, could we simplify this?
Yeah.
How?
I
10 divided by 16? That would give us a decimal.
took 2 out of each.
So we could divide both of them by 2. Divide by 2, divided by 2. Let's see, 10 divided by 2 is 5. 16 divided by 2 is 8. Wow. And look at this. If I were to go to my giant inch and count 10 spaces over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we land on 5/8. So it's correct. So if you're unconfident about simplifying the fraction, you can always go to this paper of the giant inch and just count the spaces over. All the simplified fractions will be on this sheet. Feel free to use it as you want. So our answer for number 1 would be 5/8 of an inch. There's a couple ways you can write this. You can either do 5/8 and write IN for inch, or the other way to abbreviate inches is with 2 dashes. Both are correct. For number 1, that would be your answer. Either one is good. Yes.
On my ruler, I counted 11.
Me too.
You
Counted
counted
11.
I did too.
Let's see.
I counted 11.
So if we're looking here, is it kind of right in the middle of 10 and 11 maybe?
No. It's right on 11 on my ruler.
Let me come and look at your paper.
Because I had
Let's see.
11/16 at first too.
Now it's possible that since these went through the copy machine, it could be off by the tiniest bit. If so, I'm not going to count you wrong. If it's off by 1/16 of an inch, I'm going to count it right, just because I know there's errors with the copy machine. But let me come and look at your papers and make sure you've got it lined up right. Whenever we are counting, let me zoom in again. This is what will get some of us confused. When we're counting you don't count the first line, actually. The first line is like our starting point. So it's like right here, 0. Then I go up 1/16, 2/16, 3/16, 4, 5, 6, 7, 8, 9, 10. I think some of you got 11 because you counted the first big line. We start counting after we get to 1, right? Because we're saying that this little space between the two is 1. So really you're counting the spaces. 1 space, 2 space, 3, 4, 5, 6, 7, 8, 9, 10. You're counting the spaces, sort of. Does that make sense to anybody that got 11? That clarified a little bit? Okay. And that might be a good thing to write on your giant inch paper. Here's what we can say. This is 1. This is 0. We don't count this as 1. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
That's all.
13, 14, 15, 16. So that first space is 0, or the first line is 0. Then 1. Okay. Is yours still not lining up? Let me look at yours. Okay, so let's go ahead and take a look at number 2. And we're going to go make sure we're on inches again. I'm going to line it up. Now, number 2 is a little different because we have more than 1 inch. So here's what I like to do when we have more than 1 inch, and I know that we need to include it. Right where I am touching 1 on my ruler, mark that. Here's 1. Okay, and then I'm also going to mark 2 because I'm almost to 2 inches, but I'm not quite.
Yeah, 15.
Yeah. So what I can do from here is say, how many spaces away from 2 am I? Just 1 space away. So instead of counting all 15 lines there, I could then go to my giant inch and say, well, what is 1 space away from the end? 15/16. And then we'll have 1 inch and 15/16 of an inch. So 1, gosh, focus. And then I got you next, Erica. Hang on, let me get this to focus.
15, 16.
So it would be 1 and 15/16 inches. Yes.
Is the marking of inches there optional, or do you want us to do that?
Optional. You can either do the 2 dashes or you can write the 1 and 15/16 IN to abbreviate it.
I mean marking it on like some.
Oh, instead of like an improper fraction?
No, where you went to the line and you marked the 1 inch.
Oh, totally optional. I just do it to help me keep track, and I know sometimes it helps others, but if you don't need to do that, you don't have to. No big deal. Okay. I'm going to do one more with you, and then I'm going to have you guys do some on your own. We'll look at them together. Okay, so number 3.
3 inches.
This one's exactly 3 inches, isn't it? Mm-hmm. Right on the dot. So that one is 3 inches. Or 3 inches. Perfect. All right, right on the dot. Okay, so there's 3 together. I am going to set a timer for about 5 minutes, and I want you to go through as many of these as you can. I'm going to come around and help if anybody needs it, and then we'll go over a few more together as a class. So I'll pause this and we'll come back together in a moment. Okay, guys. So let's look at a few more of these together. And what we're going to do is for each question we get to next, I want you guys to kind of shout out the measurements that you got so that we can see how many different answers we get as a class. And then we'll figure out which ones are correct. So for number 4,
3/4.
3/4, did anyone get something different? It's okay if you did. 3/4 might not be right, but maybe it is. Did every person get 3/4?
12/16.
Or 12/16? Anything else?
But I divided the two.
Yeah.
A 6 divided by.
Stop. Okay, so did anyone get a different number than either of these two?
You got both hands.
Got both of them. Good. Okay, so let's look at this. Those are both correct, by the way.
Yeah.
If I line my ruler up at 0 and I count the spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12/16 of an inch here. 12/16 of an inch. Now, that is correct, but it is not simplified. This is where we can use the giant inch paper because inside of the little inches, this is the zoomed in version. I counted 12 spaces and I marked my ruler up here. I can go to 12. 3/4 is the simplified fraction. So correct. Everybody's correct. That's beautiful. Okay, 3/4 of an inch is the simplified answer. Perfect. 12/16 is still correct. However, in the real world, a hardware store might look at you funny if you say 12/16 instead of 3/4.
Yeah.
So we do want to try to get used to simplifying our fractions when we can, just because it's going to be more useful in your real life. Okay, let's look at number 5. What measurements did we get for 5?
1 1/4.
1 1/4, 1 3/16. Any other answers? Or did everybody get one of these two?
1
I got one of them.
Okay, 1 3/16, 1 1/4 still. Those are all the same.
Yeah, the same.
Okay, so let's see. 1 1/4 would be, well, let's see. 1 inch. 1, 2, 3, 4. That would be 4/16. So we're really just looking at the difference between 3/16 and 4/16. Very, very close. They're only 1/16 of an inch off from each other. In the construction job one day, you might get in trouble for that. 1/16 of an inch off. It might make building wobbly. But in here, 1/16 is very minor. I would count both of these correct. But let's just see what we get when I put my ruler on here. So it's like we are kind of in between measurements. If I were to line it up like this, actually, this is a way better way to do it. I saw some. That's
Yeah,
smart.
yeah.
That way I can like see the lines.
Yeah.
So I'm gonna start. Here's my 0, 1, 2, 3, 4. Oh, actually, I'm past 1. Here's my 1 inch. 1 inch. So I'm just gonna count these. 1, 2, 3. But it's a little past 3. If it falls in the middle like this, I would accept either one. I'm not gonna count it wrong, either one you choose. So it could be 1 3/16 of an inch. That one is correct. 1 1/4 of an inch. I'm gonna say that's also correct because it is somewhat in the middle. Yes, Erica.
The paper does then say to round, so.
Yes.
take that into account.
So that is a good point as well, to round on your paper. What's hard to know is when I copied these, did it shrink the image at all? Did it blow it up at all? That's why I'm going to give a little more leeway, just because I don't have precise tools for giving you accurate things to measure. So it's possible that your papers are a tiny bit different sizes than mine. But that is a great point. If it was more accurate, rounding up would probably be the way to go. but I'm gonna accept both answers. Good one, go. Okay, what do we get for number 6?
1 and 5/16.
Okay, I got 1 and 1/4, 1 and 5/16.
Yeah.
Any other measurements?
1 and 4/16.
1 and 4/16. That's also the same as 1 and 1/4. So we're really just looking again at the difference between 1 and 5/16 versus 1 and 4/16. It is 1/16 of an inch difference. I'm gonna count both correct because it is so close, but let's just see. I'm gonna line the ruler up. Now this one. Actually.
5 after.
Okay, so here's 0. Well, let's count from 1. Here's 1 inch. 1/16, 2/16, 3/16, 4/16. I'm actually gonna say 5/16 seems a little more correct here. Because it doesn't look to me that it's in between markings. Now, is anybody's line not lining up exactly like this? Does anyone's go a little back? You want to make sure that the starting point of your ruler is right on the edge of that segment. You do want to be as precise as possible.
That is 5.
Yeah,
That's what I got.
I think so.
5/16.
Because here's my 1 inch, and then we count 5 more after that. It lands right on the 5 here.
Yeah, last on 5. That's why I was curious about, do we add that last line or do we not include it? If that makes sense.
So whatever line that we do reach, we do include. It's the first line that doesn't get counted as 1.
Okay.
Yeah, so it's like, here's my 1 inch right there. Then I go above to and 1/16 after the 1 inch is gone. Then 2/16, 3/16, 4/16, 5/16. Just like this is my 0 inch, 1/16, 2/16. So your first 16th starts on that little mark. And you're gonna count all the way to the line that it reaches.
Got 2.
Alright, so we're gonna go with 1 and 5/16 for this one actually. Okay. 4/16 is very close. Again, because of accuracy differences, it's possible that yours is slightly smaller than mine. I'm gonna give you a little bit of leeway on it. Okay. And let's look at number 7. What did we get for 7?
1 and 2/16.
1 and 2/16. Can that be simplified?
1 and 1/8.
1 and 1/8. Did anyone get anything different? No? Let's see. Okay, so I have 1 inch right here, and then I'm going over 2 spaces, 1 and 2/16. That is correct. And the simplified would be 1 and 1/8. Very good. Okay. How about number 8?
1 and 13/16.
1 and 13/16. Anything different than that? Everybody got 1 and 13/16. Okay, let's double check it. Put my ruler right on the line. Here's my 1. Here's my 2. Switch this over a little. Sometimes it's easier to count backwards, but if that is confusing, you don't have to. Let's see. So there's my 2. I've got 1, 2, 3 away from. Technically, this is 16/16. So 15, 14, 13 is right where it lands. So yeah, that's 1 and 13/16 of an inch. Okay. And let's do the last 2 on this first page.
2 and 15/16.
Number 10.
Yeah.
Okay, wait, what was number 9?
Half an inch.
2/4.
That's a half.
2/4 or 1/2 or what else? What did you say, Lisa?
8/16.
Yep, or 8/16. Guess what? These all mean 1/2. You're all correct. Let's double check. Yep, that is right at 1/2 of an inch.
Yeah, number T.
That longer line right in between 0 and 1, that is 1/2 of an inch. We could also count 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8/16. Okay, so 1/2 an inch, 1/4 an inch, good. 8/16 of an inch. The simplified one is 1/2 though. Hey. And guys, can you even see this purple that I'm writing with? Oh, I can't see it from here, so I just want to make sure. Tell me if you ever can see what I'm writing. Okay. And last one that we'll do together, number 10.
3 1/16.
3 and 1/16.
2 and 5/16.
Okay, hang on. Let's raise our hand. I heard 3 and 1/16 from Delon. Yes.
That's 2/16. I mean 2/15/16.
2 and 15/16. Okay. Anybody get something different than these two?
Y'all got 3.
Lisa.
In the room.
3
3 inches. Okay, 3 inches. Okay, we've got a lot of different answers here. Any other answers?
It don't even go to the 3. It don't even go to the 3 and
Okay, let's see. So I'm going to take my ruler
Right there.
and put it on here. Oh,
Smack there, right there.
that is tricky because look at this. We went past 1, we went past 2. It's not quite to 3, but it's past 15/16. So it kind of depends on if you decide to round up or round down.
Yeah.
If I round up,
That'd be
3 inches is correct. If I round down,
2/16.
15/16 after the 2 is correct. Because this is our 15 mark. Okay? So I would accept either one just because of the error of this not being perfectly accurate. And also because I did not specify whether to round up or down. And I guess directions being not perfectly clear, I'm not going to be super strict on it. Yes.
My paper is closer to the mark than the 13.
It is. Okay. See, and I bet your paper might just be a little bit, maybe it's smaller line than mine. I don't know. 'Cause mine is like right in the middle. So, interesting.
There also might be some variables.
Right. Right. That's the other thing. Our rulers, I mean, we bought rulers from different companies. It's possible that the markings are off by the tiniest bit and we would never know. So, okay. There are 10 measurement examples that we've done together now. There are 10 more on the back. We could go through this until we're blue in the face. How do we feel about measuring line segments? It's tricky.
Easy.
It's easy.
Yes.
Good. Good. That makes me
That's
happy.
what you build stuff.
So, you know what? This is something that you may need to know one day if you're trying to build something and you want to do it with accuracy. Now you know you don't always just say, oh, it's like 3.5-ish inches. No, you can go down to the 16ths. And if you go to a hardware store and you're needing parts for like a drill bit, they go down to the 16th of an inch. It's very precise. So knowing how to read those measurements is important, especially if you want to build stuff. Yes.
When you're building things, it's really important to measure it over
Yes.
because every single little error exponential.
Yes, it totally can. Because, you know, what if I tried to make all of these logs the same length and I accidentally make each one 1/16 of an inch smaller than the last? By the end, if I have my first log at like 5 inches long, my last one could be like 3 by like, it'll be so different over time. So being accurate every time, it does make a difference eventually. Okay, so that is our little activity with measuring in inches. So I would like for you guys to write your names on these. Whether you finished all of them or not, that is fine either way. Write the date, 5/27, And I actually would like for you to put these in the turn-in tray. I am going to look at these, make sure you turn them in, make sure you fill them out. And this is how we're gonna get more grades in a shorter period of time. 'Cause I'm gonna be collecting more classwork this term, just so that I can give you more grades. So go ahead and turn that in. Thank you, thank you.
Thank you.
And this giant inch paper is for you to keep. You can just keep that in your folder or wherever you like. And now I'm gonna grab a copy of this next paper that is titled Solving for X, Segment Addition Postulate. Woo! Yeah, looks scary, but I promise it's not. Don't let it scare you. Don't let it scare you. Okay, I'm gonna pause this for a moment, let everybody get set. So I am always gonna title my notes pretty much the same way. If you've taken a class with me, you know that. So let's see, this is geometry. Unit 1. And this is our day 1 notes. So the first thing we're going to write in our notes is this last word on the worksheet. Postulate. The funky word. Postulate. Can everybody say that? Say postulate. Postulate. Beautiful. Okay, so a postulate. Has anybody ever heard that word?
Nope.
Nope. Does anybody know maybe a guess of what it might mean?
Outside of math, yeah.
What's it mean outside of math?
To suppose something.
Ah, to suppose something. That actually makes a lot of sense. Got that suppose in there. To suppose something. So I'm gonna be honest, whenever I was planning this lesson, I had to look up what postulate meant because I didn't know. So basically what I have found a postulate is, find the word. It is a basic rule in geometry that we basically just accept as being true without having to prove it. So basically a postulate is like a law. Not really, because laws do have to have some meaning behind them, and postulates do have meaning behind them, but there are certain things in math that we just have to accept they are true, because if we went into the theory of why they're true, we would spend the whole 4 weeks talking about just one of those things. So a postulate is a basic rule that we just accept as true. It's just true. Basic rule that we accept. So we're going to learn about a lot of different postulates in geometry. And the first one that we'll learn about is written on the top of that worksheet, the segment addition postulate. So So we just accept that it's true because it is. So below that, I am going to write that whole phrase, segment addition postulate. Segment addition postulate. So we know what the word postulate means now. It's basically just a rule that we know is true. Do we know what addition means?
Adding.
Adding, putting things together. What about segment?
Something safe.
Like a piece of something. Yes, we just measured a bunch of line segments, okay? Because they were little pieces of lines. A full line actually extends forever in both directions, and we'll talk about that later on. But right now we're really just talking about segments of lines, so pieces of lines. So to explain this postulate, I am more of a visual learner. We'll give you a word definition, but I also would like to give you a picture to go along with it. Because when I was in high school and I was learning math, if I just had a page full of words, it would mean nothing to me when I look back at it later. So I like to try to give you pictures if possible. So I'm going to just draw a 3-inch line here. And I'm going to put points on the ends. And then I'm going to put a point somewhere in the middle. It doesn't have to be right in the middle. And we will name these points A, B, and C. Okay. So basically, what the segment addition postulate tells us is that because point B is on the same line as A and C and it's in the middle, we can know that if I add the line that is from A to B, if I add that to the line that is from B to C, I can get A to C. So let me draw a picture. Get some colors. And if you like to make your notes colorful, I highly recommend that. I think that it helps. There should be some colors at each of your tables, and if not, there's lots of colors up at the front of the room by the pencil sharpener. You are welcome to use whatever I've got in here. Basically, it means that if I add AB plus BC, I should get AC.
No, it's supposed to be CA.
CA or AC,
Oh.
both will be the same. Both work. I had a color that was like a mixture of green and orange. Ew.
Mathematically, we could also just put A plus B in parentheses.
Yes.
Plus C parentheses.
Absolutely, we could. Now, actually, I want to show you the proper notation for geometry. To notate or to write and label line segments, the way that we name them, for example, AB, we would write, I'll do it in the same color. We just write the capital letter A, capital letter B, and we put a line over it. That is the line of between A and B. Then I'll write plus. And then if I wanted to annotate from B to C, I just write capital B, capital C with a line over it, or a line segment. And that is equal to, and this is the proper formula that we're learning, actually. Proper. AC. And that's all there is to it. So I will say that this is sort of the formula for the postulate. This is just like the picture representation. This is what we're going to use as the quote unquote formula. Okay. Now, I don't know if words would be helpful to anyone. I can give you words. Let's see. If a point B is between point A and point C, then AB plus BC is AC. It's kind of written here in pictures. Does anybody want me to write it out in words? You do? Okay, let's write it then. If a point B, okay, so right here. If point B is between A and point C, then E equals A. That's the word version. And then these are pictures to help. So let me just say that that is the postulate written as a formula. Even if you just have this written down, that's fine. Whatever helps you remember best, you can write it. I'm not checking your notes. Although I would recommend writing notes because in case you didn't know, every quiz is open note. So if you take great notes, you'll do great on your quizzes. Okay. So for example, I'm gonna write example under here. Okay. Also, I had to tell you, I thought of you this weekend. I went specifically to Walmart so I could get this pink pin because I loved yours so much. And I like my favorite now. Okay, so for example, let's see. I'm going to draw a line segment. B, D. And I'm going to say that from A to B, we have a length of, let's not get too fancy. I'm going to 25 inches. Okay. From B to C, half an inch. That'd be crazy. What if we go with like 3 inches? Is that okay? 3 inches. We're gonna do super simple as our first example. So A to B is 25 inches. B to C is 3 inches. Can you find the measure of A to C? 28 inches. Yeah, you just add. That's it. I can use the segment addition postulate. I know that since B is in between A and C, well, from A to B is 25, from B to C is 3. 25 plus 3 is 28. So from A to C would be 28.
Plus,
Yes. So I'm going to write out how we would solve this. So A to B. This is how I would do it. I would start by labeling my drawing. A to B is 25 inches. So here is 25 inches. From B to C is 3 inches. So I'm going to write 3 inches right here. If I want to know A to C, I want to know here to here. When you see it written like this, is it a little easier to tell that we need to add them together?
Mhm.
Yeah, sometimes just labeling your picture helps quite a bit, especially if you're a visual learner. So all we did was 25 plus 3 equals 28 inches of your answer. You can see where we're going with it. All right. See how we did that? Okay, any questions about the example we just did before we try another one together? Okay, let's try another one. How about, let's use different letters this time. How about we try QRS? Just for fun.
Oh, good question.
Q R. Let's say QR. This time I'm actually going to just label the picture from the get-go. Let's say this is 15 inches from Q to R. And let's say from R to S is 55 inches. How would we find the length of QS?
70.
How'd you do that?
Add 15 and 55 together.
Yep, we're just going to how to get there. Okay. So let's write that out again. All I did was my QR plus RS gives me the QS. QR is 15 inches. Is 55 inches. That's you. And so that should give us U to S. Is that right? Let's see. 55 plus 15.
It's 10,
5 and
carry
5 is 10. Yep, carry the 1, 70. Beautiful. Okay, so 70 inches is our length overall. Very nice. Not so bad, right? Not so bad. Now, it does get a little trickier. This is more of the simple version. This is more explaining the concept. Here's where it gets tricky. What if I gave you this. Now, if you know how to do it, don't say anything yet. Give everybody a minute to look at it and write it down at least. Use TUV. Okay. This time I know from T to V, I have 123 inches. E to U, I have, I don't know, 75 inches. Now don't say it out loud if you know how to do it. Give everybody a second to try to figure it out on their own. How could I, don't say it out loud, how could I solve for U to V? Think about it for a minute. I'm gonna give you a few minutes to think, and then I'm gonna give us a minute to share if you think you know how to do it. Right over here. E, V. Feel free to talk with your neighbors, talk with your classmates, see if you guys can figure out how to do this one on your own. I'm actually gonna set a little timer. Talk with each other, see if you get the same answers. I will pause this for a moment. Okay, if you think you know how to do this and you have an answer, raise your hand. Titania, you want to tell me about it? How'd you do it?
I subtracted 75 inches from 123 inches and you get 48 inches.
Yes, absolutely. Okay, so did anybody else get 48 inches? If you did, you are correct. So here's what she did. The total amount from T to V is 123 inches, okay? So we're going to kind of look back at that segment addition postulate. AB plus BC is AC. Well, TU plus UV must make TV, right? So TU is 75 plus UV, we don't know, question mark, equals TV, that whole 123. What you just did without doing it is basically we set up an equation and we solved for X. So to get rid of 75, here's what the math happens. Minus 75 on both sides. And there's where your work came in, 123 minus 75. You did that without needing to set it up because whenever you have a problem like this, sometimes you can just recognize that, well, 75 is part of that whole. We're missing this. So if I take the 75 away, whatever is left will be my answer. So I'm taking 75 away from the whole, which is 123. And our answer would be 48 inches. Any questions about that? Any questions? Anybody lost? Anybody lost? Maybe a little bit? Or do we get it? We feel good? Okay. I like that. All right. Okay, so where it gets a little more complicated is on this next paper that we're looking at. And I do want to point out and realize that it is 11:41. We have 15 minutes until lunchtime, and I always try to get you out before lunch. So let's consider looking at this a little sneak peek. We'll do one together. If you don't quite get it and it doesn't click the very first time, please don't freak out. It will be okay. We're gonna go over this more tomorrow. But let's just get a sneak peek of what tomorrow's lesson will be. So let's just take a look at number 1. Ah, man. Great. Question? Huh? 15. Number 1? Well, I haven't worked it out yet, but I will let you know when I do. Let's see.
No.
So I'm gonna look at number 1 here. Let's ignore the fact that there's a bunch of letters right now. Let's ignore the variables. Don't let them scare you off. Let's just look at the HGF. There's 3 points. There's 2 sections. There's 1 whole big line segment, okay? So my first section is H to G, okay? My next little section is from G to F. My whole is from H to F, or this length here that they're giving us, the X plus 20. We're going to set up an equation, and here's how we're going to do it. All I'm going to do is look in the order that these are written, and I'm just going to like copy it down. From H to G is 2x plus 20. Let's write down here 2x plus 20. So there's that first section. Then we're going to add that to the next section, which is just 7. So I'm going to write plus, because I'm adding it, we're using the addition, plus 7. Okay? And when I put these 2 together, it's going to give me the whole length, which is S plus 20. We don't know the length yet. Don't let that scare you. We're going to solve for it. Okay? So it equals this whole length of X plus 20. Okay? So, do you see where this came from? We're just pulling it out, putting it together. Don't let it scare you too much. Yes.
What is a practical application? It's like saying you're building a fence.
Great question. I don't know. I don't have an answer for you. It's in our curriculum, so we're going to learn it. Let me get back to you on it. Maybe I can find something tonight that maybe you'll actually use this in real life. For now, I'm going to say it's because it is part of our curriculum and we're just going to learn it. So let's look here now. We just have an equation. I'm going to kind of trace over this in one color so it doesn't look too crazy. 2x plus 20 plus 7 equals x plus 20. What's the first thing we should do when we're solving an equation?
Get rid of the X.
Get rid of the x's? What do
Get on one side.
we want to get our variables all on the same side of the equal sign, okay? We're going to combine like terms. So, would it make more sense to subtract 2x or to subtract x? Subtract x. Let's get rid of the smaller one first. Minus x. Where else would I subtract x?
Under this one.
Under the 2x minus x. Okay? These cancel. What's 2x? Take away an x. Just x. Now I have x left. Now I'm going to bring everything down. Plus 20 plus 7 equals 20. Do I have any other like terms that I can combine? 20 and 7. These are just regular numbers without variables. We can change that to 27, can't we?
Yep.
That would be a lot less crazy to look at. So let's just put these together. Now I have x plus 27 equals 20. How do I solve for x from here?
Don't you add 27 on both sides?
Well, I'm starting with plus 27. How do I get rid of plus? Ah, yes. Minus 27 on both sides. Those will cancel and we get x equals what?
Negative bonus. Negative.
X equals -7. And that's our answer. I think it's kind of cool. I don't know. Did anybody get that without me showing you?
No.
He did.
You got it? That's
Gene was-
amazing.
Gene's ahead of everybody.
I love it. That's so cool. Okay. So that's our sneak peek. We're gonna get more into this tomorrow. Yes.
This is just what we covered in the algebra too.
Basically. Yes. Pretty much. We're just applying it to shapes now. Okay, so that one you will turn in. Yes, remember if you were not in here when I said it, please turn this in the measuring line segments paper. This one, solving for X, keep it in your folder because we're gonna use it tomorrow. Okay, keep it in your folder. Don't leave it. We're going to use it tomorrow. Likely for a little activity at the beginning. So we'll move from there. That's all today, guys. I will see you tomorrow. Have a good lunch.